Hi, my name is Rachel Marquardt, and today I'm going to be talking about physics in cheerleading, or more importantly, the physics that can be found in cheerleading. When most people hear the word cheerleading, they automatically picture the typical young girl with a sparkly ball in her head yelling and shouting for the football team. However, there is much more to cheer than that. The main components of cheer are stunting, tumbling, and jumping, and that's where the physics comes in. The main aspect of physics in cheer that I'm going to focus on today is Newton's laws. Newton's first law states that every object in a state of uniform motion tends to remain in that motion until an external force is applied to it. Simply put, this is the law of inertia and means that an object in motion tends to stay in motion unless acted upon by an outside force, and vice versa, where an object at rest tends to stay at rest unless acted upon by an outside force. In cheer, this comes into play when putting a basket stunt into the air. A basket toss is when the bases and backspots throw the flyer in the air, and then she comes down and is caught in the base's arms. As the flyer is tossed out of the base's arms, she's thrown into motion. However, eventually gravity, which acts as an outside force, causes the flyer to return back down safely to the ground. The flyer is the object in motion, and she continues to remain in motion until gravity again acts upon her. Newton's second law of motion states that the relationship between an object's mass, its acceleration, and the applied force is F equals ma, or force equals mass times acceleration. Force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second squared. In cheerleading, this is important to tumbling. A tumbling pass is when someone runs into a series of connected flips. Newton's second law can be used to explain how a tumbling pass works. As a cheerleader begins to run for her tumbling pass, their acceleration increases, therefore increasing the overall force of the skill. So this means that the faster or harder a person runs, the better and more powerful their overall tumbling pass will be. The third and final law of motion says for every action there is an equal and opposite reaction. As is the case with all these rules, this law can be applied to almost every aspect of cheer and life for that matter. However, I'm going to focus on how it applies to jumps in cheerleading. When I bend my knees to do a jump, they push off the ground, acting as the applied force to cause upward acceleration. Yet we know there has to be an opposite reaction to this force, which comes from the gravity. Gravity causes me to accelerate downwards back to Earth, which would make it the opposite reaction to balance out the applied force. In conclusion, this is how physics affects my life on a day-to-day basis at cheerleading or tumbling practice. Whether I'm stunting, jumping, or tumbling, understanding Newton's 3 laws of motion has helped me to become a better cheerleader.